information processing. This is a diagram that is in one of the videos, but I just kind of want to walk through it and give people an opportunity to kind of comment on what's meaningful to you, what part of this kind of speaks to you about thinking about the way that you learn. And I want you to, as I walk through it, to kind of really think about what it is that speaks to you, and think about your own learning. And of course, as teachers, we all kind of think about examples from our classroom, but I think that with this model especially, it's really helpful to for us each to be able to kind of call up those examples for ourselves. So this model says that everything starts with an input from the outside world. And I think if when we are thinking about our knowledge in the present tense as adults, we have a lot of things that we already have inside of us somewhere that we can call up memories or any of that. But if we really think about the process of development from the beginning, from a very young child to adulthood, everything that we even can call up to think about somehow started outside of us. So we took it in through one of our senses. So that input from the outside world, there's lots of it that comes into our sensory register. And if you think about at any given time, the amount of information coming into your sensory register through your eyes, your ears, your sense, all of your senses, your sense of touch, we're taking in a lot of information all the time. And most of that is lost. Most of that we don't pay attention to, we don't attend to it, and therefore we don't notice it. And my favorite example of that is actually the example of jewelry that, when you first start wearing a new watch, or you put on a pair of earrings, or you're wearing a ring, you're really aware of it. You really notice it. It comes to the forefront of your mind a lot that first day or week. And then over time, you stop noticing that it's even there. You kind of adjust to it, and it starts to be something that's lost all the time. And I think, especially as we think about our students who struggle with paying attention, being really aware of the amount of information that's coming in through their sensory register is really meaningful. The first semester when we taught this class, I had somebody point out that they had initially said, oh, well, because we know reading and writing is important, I'm going to put up more words on my walls so that kids have stuff to read all the time. And she did that, and then we got to this part, or she was thinking about doing that. When we got to this part, she realized that actually covering your walls with things adds a lot to the sensory register, and it really makes even more things for kids to decide to pay attention to or not pay attention to. And so it actually, this becomes something that we don't always think about, but is a huge factor. And so then we have all these things coming in, we choose to pay attention to them or not pay attention to them, and the things we pay attention to go into our working memory. And that working memory is limited. It is not an unlimited, we can just keep shoving more things in there. There's a lot of debate in the research world about what it means to say that's limited. The conventional statement that people have used for years is the idea of 7 plus or minus 2 items or chunks of information that can be in there. We can't really pay attention to more than that at once. And of course, the great urban legend is that that's why phone numbers have 7 digits, because we can remember that many. I've heard a lot of people kind of challenge that assumption and say that that's not true, that just sounded good at the time. But there really does seem to be a very real limitation on how much we can pay attention to at once. The things that we pay attention to, we process and encode them, and that's what transfers them to long-term memory. One of the really important things here is that I was careful about what I said. I said things or chunks of information. I didn't say items of information. I didn't say numbers or letters. And I think that if you reflect on what it was like to learn to read, for me, that's a great illustration of what a chunk means. When a kindergartner is first learning their letters and they have to sound out the letters, the idea of reading the word cat is overwhelming, because the shape of the C is one piece of information, and the sound of the C is another piece of information. The shape of the A and the sound of the A, and the shape of the T and the sound of the T. And with the A, when I think about the sound, there's maybe 3 different things that I might know that A could sound like, and then the thing of them all together is a cat, and I'm probably pretty literal still, and so I can imagine I then start to think about things like what a cat touches and feels like, and the fur and the noises, and now all of a sudden I have 7 things in my head on just that one word. Trying to link 4 words together would be way too much. But as an adult, when I look at the word cat, I see the word cat, it's all one thing. It's one chunk for me. The object of a cat and the word of the cat and the sound of the cat. When I think of that, that's just one chunk of information. And so as we learn and we process, what we're actually doing is forming all of those separate pieces into one chunk. And then that's what allows us as we get older to appear to be able to do a lot more with our working memory. And so this, and then up at the top here, you have this central executive control processes, executive functions. Different people call that different things, but that's where we make a decision. We make a conscious decision to ignore that person talking, or to block out all of the other things that are trying to catch our visual attention. I know I often make the decision to close my eyes when I'm listening because I can't take in information with my eyes and ears at the same time. It's overwhelming for me. And we also make decisions here in processing and encoding. Am I gonna recite that list over and over again? Am I going to make up pictures in my mind about that list? What is it that I'm going to do to try and make those connections to chunk that information together? So the overall model of information processing really does rely on this or a different version of this model of memory. So I wanted to kind of go through that, and I know for those of you who've watched the video, some of that was redundant, some of that was said in the video, but just to kind of give a refresher on that. So as you look at this and as you think about those pieces, I want you to kind of tell me, what are the parts of this that speak to you, that you can recognize this in what you do, in your experience of learning things or interacting with the world? And you also can comment. Lindy wrote a question in the box about, did anyone memorize the list in the TED Talk? Which I did not. I tried to memorize it, but I couldn't because there was too many other things going on. I couldn't stop to listen enough to memorize it. So what are your thoughts about this model? Does it resonate with you as something that's real for how you learn?
I think that TED video I did, I made a little story. I'll answer Lindy's question. I think. Oh. Sorry, Lindy, go ahead. Oh, I was just gonna say, I made a little story in my head. I watched it 2 weeks ago, but it was like Saturn and rear view mirror and road. It seems like somebody was driving down the road in the mirror, and Jupiter, that was the word. And so like the whole time I'm waiting for him to ask for it at the end, and he never did, and I was really disappointed.
That's fantastic. I love it.
Yeah, I agree, Lindy. I had to connect it to actual objects. I didn't do it through a story, but by visualizing the world around me. So in that sense, this model seems to work in that, what I'm focusing on will only go into my long-term memory if I can really put some sort of greater meaning on it and move it there. Otherwise, those facts just kind of float out the window.
The thing I want to say about the story that you told, though, Lindy, is that what you told, the pieces that you told, were all about how you took all those pieces and made one chunk. You made them into one cohesive image, and that image had all the things in it. And that, I think, is, I think that we do that a lot, and students do that a lot too, where we connect together those images. I know for the other thing that I'll say is that I know for myself, and I already said that I have to close my eyes if I'm going to listen. I'm definitely not an auditory learner. I really struggle if somebody wants to tell me something. I have to ask them to give it to me in writing, write it down so I can look at it. But I have a really strong connection to scent, and so there are some shampoos, like there's a shampoo that I was using when I was in college for a while, and if I smell other people have had it, like I start to have get a little bit anxious about the tests and all the things I had to learn, and it's all really connected for me to smell. And so I think about how that's just one thing and I'm just one person, but how all of my students probably have things like that, that if I'm not aware of all the different sensory triggers that are in my classroom, I can really trigger a lot of things without realizing it. Okay, I'm gonna go to the next slide. I have a few questions, and these are guiding questions that go along with the reflection. But I want to talk as a group about some of these, and I asked you to think about the model as a learner and your experience of it as a learner. But in this one, I want you to think about either as a learner or a teacher. But in your in your classroom, when you intentionally use or either as a learner or in your classroom, when you intentionally use strategies for elaboration, organization, meaningfulness, or metacognition, what are the strategies that you find most useful?
I was thinking of 4 words that we had to, the 5 words, and what I did, and imagery is the best thing for me because I can put a story to it. So I did like, I love trees, and then I'm driving down the highway, and the mirror was in my car. And then the fourth one I missed, but the fifth one was electrodes. So I'm not sure where I dropped out on the fourth one, but I had to turn it into a story.
So making stories or using imagery is a really good one. And I think that we do that a lot. I think about, I mean, if I'm trying to think about science content and about ways in which we use that, and I've seen a lot in elementary and middle school classrooms, especially, but also high school, where we make stories out of the body systems. I think about like Magic School Bus and the ways in which these like little characters are traveling through the different parts of the body system. I think that method of elaborating through stories and visual images is very common. What about organization?
We use a lot of um, graphic organizers and things for students to improve their comprehension skills, and those seem to help.
Yeah, graphic organizers are great. I also think about the degree to which with organization, like if we take something like the planets, the ways in which we really ask kids to think about their distance from the sun, their size, which ones are gas giants, which ones are rock, which ones are hot, which ones are cold, um, who has the longest year. I mean, there's so many different ways in which when we present information, we encourage students to enforce those kind of layers of organization onto it to help them to learn and to help them to understand, because that helps them to make meaning.
I don't know
I'm
if
an
the
incredibly visual learner myself, and I find that I can remember things better if I have written them and I can like see them on the page. So for me, taking sort of copious notes and taking what someone is teaching me and putting it down on paper where I can almost visualize it in my mind when I'm away from my paper is extremely helpful for long-term memory.
for myself, I have to write everything down. If I want to remember it, it has to be written down, taken notes, and that's what I have to do to learn.
And I think for me, as I think about my role as a teacher and things that I can do to help students to learn, um, really memorizing those three things, providing them opportunities for elaboration, opportunities for organization, and opportunities for making meaning or meaningfulness. Um, really internalizing for myself that every time we come across new information, we should be doing those things. And then to realize how much of the time it does involve reading or writing, making meaning, organization, and elaboration, all three of those require us to read and write. Really, for me, has given me a stronger understanding of why we can't leave those things out of science instruction. I'm gonna
I
skip
saw an
it.
article
Oh,
this week. Oh, sorry.
go ahead,
We need a
Lindy.
hand raising thing.
I know.
We need a hand raiser. I remember seeing something come across Facebook or something about one of these head honchos, these guys that think about teaching but haven't taught in probably 30 years. But he said we're wasting our time if we're teaching kids things that they can look up automatically. Anything that could be Googled, we're wasting our time trying to talk about. So do you think that applies to what we're trying to help kids to have long-term memory?
Oh, well,
Oh, well,
first of all, I agree
first of
that,
all, I agree that,
oh, I'm gonna have to hit
I'm
mute
going to
again.
have to hit it again.
Um,
You did.
first of all, I
First
totally
of all,
agree that that um sorry, I completely lost my train of thought now. I agree that we need a hand raising thing. That's for sure. And there is another version of this where you can raise hands, but we aren't using it this semester because it's a pain to get into. But I'm considering asking permission after today to use it. But um, it's hard because I agree with what he says, right? That if I'm asking my students to memorize the order of the elements on the periodic table, I'm probably wasting my time. They can look that up. We live in a digital world. It's better for me to have them make meaning of the order of the elements on the periodic table, really understanding how did they get put in that order, why are they in that order, what does it mean that they're in that order, is far more important than being able to say, well, great, I know that oxygen is 8, but can I name the ones up to oxygen, and does that matter? Um, and so I think, um, on the one hand, that person has a point, but on the other hand, you can't learn how to use Google and how to use that information if you don't spend time working with something. And so I would hope that we can interpret those voices, those people who are saying those things, I would hope that we could interpret that as it matters less which pieces of content we're teaching students to reason about, because we can look most content up somewhere. It matters more that we're teaching them to reason, we're teaching them to learn, we're teaching them how to elaborate, how to make organization, and how to make meaningfulness, that is far more important than any one piece of content. And I think sometimes that message gets lost because we just get so focused on, well, it's a Google world, we can look that up. But we need to make sure kids know what to do once they've looked it up. Which you've got to use some kind of content to teach that, to teach those skills. I don't know if that answered your question, Lindy. I there we go. So I had a separate slide for each of those, and I didn't change the slides. So I want to just spend a little bit of time talking specifically about metacognition. And in some ways, metacognition is different than elaboration, organization, and meaningfulness in that it kind of has its own world. We're choosing to put metacognition here because actually the process of establishing meaning and establishing organization, those are all very similar, or they all are part of the metacognitive process. If I've organized the information, I'm going to be better able to be metacognitive about it. And so one of the things that is in the readings and the presentation is this idea that there are values that influence our metacognition, that how we perceive the task has some influence on whether we can be metacognitive, the strategies that we would use to improve our learning and when and where to apply them. So understanding that using elaboration through imagery is going to work really well for a disconnected list of terms, but creating organization is going to work better for memorizing the planets because there are these organizing features to the planets, being able to be aware of why those would work. And then the third one is the person and learner understanding our own capabilities. So like for me to be able to say, wow, I'm a really linear thinker and I'm a really visual person. And so the most important thing I can do is to create a diagram on a piece of paper that represents what I understand about something. That's going to help me most. That's not going to help another person as much. necessarily, because they are a different person, they have different capabilities. And so I really kind of want to focus in on this question of strategy and how metacognition fits in with strategy, and how is it that we can help our students to understand, not just that we give them graphic organizers or that we ask them to create a table of information, but how do we get our students to really identify when and where and why those strategies matter? Since we don't have a raising hand, I could just call on people, but that's not nice.
I'll be honest with you. I'm having a hard time, I guess the word is assimilating all of this information. It makes sense on the surface as far as what the definitions of the words are, but to pull out an application, it's not working.
Thank you. That's really helpful. So for me, let's see, I'll try to think of an example. So I taught high school, right? And the ways in which we would help students to apply these strategies would vary a lot at different age ranges. In high school, what I would do is I would do things like I'd lecture. We'd go through and I would do direct instruction on the material, and they'd have some readings. But then I'd ask them to, in their groups, think about, if you were going to create a study sheet for this material, what would you do? Or if you were going to teach this material to someone else, what would you do? And I would ask them to, in their smaller groups, really think about and articulate, with this information that I'm doing, what's my best approach, what's my best strategy to use, so that they are thinking about the information and about themselves specifically, what's going to work best. I don't know if that helps at all.
A little.
I'm just trying to expose them to all different kinds of things. I teach elementary, and to say, how do you think about this, or how do you think about this, they just look at you. But as I'm trying to teach different note-taking skills and that kind of stuff, I'm hoping that maybe they'll grab onto something that will help them when they're older.
Yeah, so I think asking them to comment on whether this is working for them, whether this is helping them, whether this is a good fit, and then being explicit that I'm giving you this as an example that you might use later, having them say what they like and don't like. I think that's those are really helpful strategies. I think, it's the idea of teaching metacognition explicitly in the classroom. When we say things are new ideas in education, new ideas take a while, so I think that it's probably been 10 years since researchers started pushing on classroom teachers to really be aware of metacognition. It's probably been 30 or 40 years since researchers started talking about metacognition. But I think it is a pretty new idea to be open with our students about having them think about their thinking. And I think part of it is when we think about the task and the strategy and the person, if we were to, and I'm going to go back really fast, so sorry. If we were to go back and think about this right here, every student, every learner has to make choices about their processing and encoding. And as teachers, sometimes we hold their hands and we say, you're going to do this activity right now. And the activity that we've set them up for lets them process and lets them encode, and it kind of happens without them thinking about it. And what we're really talking about when we say we want to help students to be metacognitive, we want them to think about their learning, we want them to be aware of the strategies that they're using, is that we're trying to make this an explicit process so that when they go to college or they go to the next grade level, whichever, they're able to say, wow, nobody told me how I was supposed to learn my vocabulary list this week, or how I was supposed to memorize the parts of the circulatory system, but I know these are the things that I've done in the past that worked for me. And it really is about making it explicit. And so often the ways that we make it explicit are involve reading and writing. The ways that we process and encode involve reading and writing. The other thing that's in this week's reading materials is if we look specifically at metacognitive strategy, not just learning strategies, not saying, well, a strategy would be to use, I'm comparing and contrasting things. My strategy could be to use a Venn diagram, right? That's a very specific strategy for elaboration. It allows me to think really critically about what's common and different about two things. As I write it down, I'm elaborating, I'm processing, I'm really going to have a better chance of remembering. There are 4 strategies that we talk about that are specifically metacognitive strategies, and so they're not strategies that are elaborating specifically about a topic, but they're strategies to help students to really think about what their progress or what they know. So those are the goal setting or planning, the idea that we have a goal and we've decided how to reach that goal. I think we use the goal setting and planning strategy a lot when we ask students to do large projects, research projects. We ask them to define their final goal and set out a plan of how to get there. But that goal setting and planning strategy can be used for smaller tasks as well. Monitoring. If I use that example of the Venn diagram and the compare and contrast, if I've been given 2 objects and I say, oh, compare and contrast, Venn diagram, that's a strategy I could use. I'm going to make a Venn diagram that at some point I might check in and say, wow, there's not actually any overlap between these on my compare and contrast. They're all different. The Venn diagram wasn't a good strategy. So kind of being able to stop and ask myself if it's working. And then affecting that while I'm monitoring, that I can actually say this strategy isn't working. I'm going to use a different strategy. So, for example, if I said, hey, creating a visual image always works for me, and what I've been asked to do is memorize the order of the planets in the solar system, halfway through, I might say, wow, that is not working for me. I'm going to actually pick a different strategy. I'm going to decide that organizing the information is going to be better because, hey, look, all the gas giants are next to each other. If I can organize my information around the type of planet, I can do this in a more meaningful way. And then at the end, when you take the test or you have some kind of an evaluation of what you've learned, being able to go back and say, these are the strategies that I used, was I successful or not successful? And to be able to actually articulate why those worked or didn't work for future use. And so I think as we really think about how students encode information and how they learn information, which, you know, even though we live in a Google world, we really do need to teach kids how to take that information in and how to put it in long-term memory, whatever information we decide to use. Being really aware of helping students to know what worked and what didn't work is the end goal, so that in this Google world, when they go to look something up later that they need to take in, that they'll have the strategies that they need to do that. Which of these do you think, when you're working with students, which of these parts of being metacognitive do you think is hardest? Do you think it's hardest to have them plan out what strategies are going to work for them, monitor whether things are working, change their strategy when it's not working, or at the end really evaluate whether things worked well? Which one is the most difficult with kids?
I think for me, the effect one would be the most difficult, because if I'm struggling on how to figure out how I'm learning, how am I going to help the kids figure out what they're learning, and then to change or adjust as needed during the learning process? That's kind of where I'm at.
Yeah, I agree. I think that affecting is really difficult. Even if we identify that what I'm doing isn't working, um, changing midstream is hard.
I think students don't always realize when something's not working. So they might think it's working, but it's really not.
So that would say that monitoring is really the issue,
Yeah.
right? That like affecting is hard, but the even harder than that is getting them to acknowledge that it's not working. Um, I have a third grader who really is a terrible speller, and I say that with all the love that I have. He cannot spell to save his life, and we have tried so many different strategies, and getting him to acknowledge that the strategy of just reading the words doesn't work is like pulling teeth. Getting him to acknowledge that the weeks when we get him to write his words out multiple times, that he gets a better grade. He won't even, he refuses to acknowledge that that worked. I mean, so I think that that's huge, that getting kids to actually monitor themselves and acknowledge that things did work or didn't work is really hard.
Also, I think maybe with the goal setting, if all of these, you have to model it enough so that they understand how to do it. So goal setting, and it has to be personal sometimes. We as teachers or educators often just we set the goals on everything, like you're going to learn this and this is what you have to learn today, but giving them some chance to be independent goal setters. And then evaluating, we used to just set goals in third grade by the week, and then at the end of the week, we went back and checked them off. So there was a structure there. There was a way to evaluate.
And I think that a couple weeks ago when we read that Getting Past Just Because article, they did have some good tools. I mean, even just pieces of that, the tools, the ways that they set up their conferences, the ways that they talked with kids about what was good and what wasn't good in their writing, that some of that could be modified for this purpose as well, of really having one-on-one conversations with kids to check in on how they're doing with this. And I think, we're gonna this is I think there's only one slide after this in this week's materials, and when we first kind of were doing our first pilot and review of which theories we were putting in, somebody kind of pushed back and asked why we were including information processing in here, and how did that really tie to the Common Core. And so I actually want to, that's the last slide, is to kind of explicitly address that question of, so what does this have to do with the Common Core standards? And I've kind of alluded to it a few times, but I think it's really important that, the Common Core standards for reading and writing ask students to integrate multiple pieces of text. And if students aren't able to be metacognitive about saying, wow, I watched a movie and I have a graph and I have a reading and I heard my teacher talk about this, and I have to come to some singular understanding of this that I can repeat back out to demonstrate my knowledge. And obviously those aren't the words that a child would use, but as we ask kids to do that and really integrate multiple representations, kids have to have explicit strategies for that. And maybe it's a graphic organizer that asks them to write down what they got from each different representation, or maybe it's a structured writing method that they're going to use. But all of the different things that the Common Core asks kids to do really puts heavy demands on that encoding and processing part, because we are asking kids to work at a higher level of Bloom's and to work at, whatever different, or if you want to talk about depth of knowledge or Bloom's or any of that, we're asking kids to get up to that level of synthesis and integration, and that takes some special skill sets. And so being aware of the information processing model and understanding what it really means to take all that in and process it becomes an important step. And that's why we included it, because we really wanted that to be explicit, that we can't just say, okay, here are 4 things, go and do. We have to understand more about what's got to go on inside of their little heads when we ask them to do that. And of course, you could take a whole semester-long class just on information processing, but hopefully this little taste helped. We have about 10 minutes left, so I wanted to kind of open up, and if people have questions about the reading or about the theory more generally or any of the other stuff that kind of came up this week, uh, that we can address or answer or help with.
I have a question about my kids struggling with like learning the multiplication facts.
Yes.
I don't remember it being so difficult when I was a kid, but it seems like it's impossible to them. What would make it easier? What is causing them not to learn them?
So I would just ask, what was it that you did when you were a kid?
I have no idea.
So I know that when I was a kid, I had flashcards and my mom quizzed me. I know that my kids are not bringing home multiplication facts flashcards, and I know that I'm not being asked to quiz my children.
Because as teachers, we've been taught that that's bad.
Right. So the question that I would ask then is, memorizing multiplication facts just gives you that memorized part. And what we're doing with kids might make it so that they aren't taking the time to memorize. But if I ask my son, who's in 3rd grade, to explain to me what it means to multiply 4 times 5, he can explain to me the concept of multiplication in a way that I never could when I was a child, because all I did was memorize the facts. I memorized them as strings of numbers. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. I just memorized those, whereas my child is learning that 5 times 4 is 20 because I can take 4 times and add that together and get 20. And he's using his time to do that instead of memorizing. So those of you who are in those early grade classrooms, you know more than I do about exactly what's happening during math instruction. But I think that the focus has become more on understanding why those facts exist.
And I agree to that, but when they go on to 4th, 5th, 6th, and middle school, they're expected to know them, and they don't.
Yeah, and that's a vertical alignment issue that we need to fix. Do we have any middle school teachers who can speak to that? Whether is that something that's changing in middle school, that the expectation that students without a calculator know their multiplication facts?
I can't speak to middle school, but I know in high school we still expect them to do basic math without the calculator. So, more elaborate stuff that uses scientific notation, yeah, go ahead and use the calculator. But if you can do 23 times 5 in your head, that's a great thing. And, a lot of struggling with that even at the high school level.
Right. If they can do it longhand on a sheet of paper, but can't tell you immediately 23 times 5 is 115, right? Is that like it is the expectation is that they can do it in their head or that they can do it without a calculator?
It depends on what level they're at.
Yeah.
Freshmen coming in, if they still need to work it out on paper, fine. But by the time they get done with Algebra 1, they should be able to do some of those simple math problems in their head.
Yeah, and I know some things about math, but I am not a math expert. I prefer science. My hope is that what we see is that more and more kids are able to say, I never memorized what 23 times 5 is, but I know that there are 5 20s and 100, and I know that 3 times 5 is 15, so 23 times 5 is 115, right? That they can reason through based on their understanding of what multiplication is. But I think it'll be a while before we figure out at all different grade levels how we support that type of an understanding, instead of either just saying, well, as long as you get the concept, you're fine, or saying you have to memorize everything to have kind of a functional understanding. In the middle, I don't think that our schools have figured that out yet. And I would love to say that the adoption of the Common Core math standards answers that conclusively, but I think it'll take us a while to figure out what that looks like in practice. Do you guys like how I punted that question? That was pretty good, right? So yeah, education's hard. It's really hard. There are no right answers. And I love on our call today, I know for sure we have Hardin and Billings. Renee, where are you from?
Luster.
Luster. Yeah, so okay, that's fantastic. So we have Hardin and Luster, which in theory have relatively similar populations, but are nowhere near alike, right? Because Hardin has easy access to Billings, and Luster has easy access to nowhere, unless you count
pretty much.
Glasgow as a large city, which I do not.
Yeah.
And then you have Billings, which you're like right in the middle of a huge town. And so then when we look at these questions of like vertical alignment and what our kids are getting at home, and I mean, it's such a huge variable. And so I think that's why it's so important, I think, that individual schools are having very real conversations about this stuff. You know, they're really being open and honest about saying, when I send homework home, there is an adult who understands this that is working with a child, versus it really all needs to happen here in this building, because I don't consistently know that my students are going to get help at home or have somebody at home that even knows these things. I remember I was volunteering in my son's classroom, my older son, when he was in 2nd grade, and I would go in and I would read with them, and we were living outside of Madison, Wisconsin at the time, and it was a very diverse school. In his kindergarten class, 50% of the kids in his kindergarten class spoke a language that wasn't English as their first language at home. One of them even spoke Egyptian. I mean, it was just incredibly diverse. And so in 2nd grade, I was coming in and I was reading with the kids, and this kid I was reading with, and he said to me, I want to quiz you and see if you can guess the end of this story. And I said, I can't, that's not fair, because I've read this book with my son before. He said, oh, you come in and tutor your son? And I said, no, like, he brings a book home for me to read with him every night, and I read with him. He's read this book to me at home. I said, don't you take a book home to read? And he said, yeah. I said, who do you read it to? He said, I read it to my little sister. And I said, so when your parents are home and you spend time with them, what do you do? He said, I play Grand Theft Auto when my dad's home. That's what I do with my dad. And I thought, you have these two kids sitting next to each other in class, and what the strategy of that teacher should be is completely different. For my son, who's actually reading to his mother getting a doctorate in education, and this other child who's going home and playing Grand Theft Auto with his dad and reading to his baby sister. I mean, it's just education is such an individual thing at that point, and we really just have to be aware of who our kids are and how they learn. So there's my thought-provoking message for the week.